Hey everyone, this is your weekly episode of the Zephyr podcast, where we talk about all things Zephyr, embedded, cool, open source news. This is episode 15. I am Benjamin, your co-host.
Hey, I'm Fabio, your other co-host. What's up, Benjamin?
Hey, just back from Paris. I gave that talk about the Cyber Resilience Act. I was, I guess, briefly mentioning last week, but yeah, we can come back to that in a few minutes. It was it was an interesting trip. How about you?
I've been to Italy. I was in Verona playing video games. How about that?
Oh,
uh,
wow. Well, I don't know what I
yeah,
would enjoy the most. Like, I mean, that sounds like video
I
games
can tell
in
you.
Italy. That sounds like a
Yeah,
plan.
yeah. Well, so this was a retro LAN party with my old friend from university. I don't play video games anymore. I'm too old for that. But it was fun, and there was a lot of Zephyr in it. So I showed up with a bunch of WASD 4-key keyboard, gaming themed with like RGB LEDs and everything. It was a great success. They loved it, and I played on those and on my Zephyr based mouse, which worked well. Although I tried it over Bluetooth Low Energy, and I'm sorry, wasn't good enough. bit
Oh,
of
and
bit of latency.
how about the keyboard? Is this also Bluetooth?
No, the keyboard was USB. I made 15 of those, so and I didn't want to bother with batteries and everything, so I just went simple. I should publish it. Great design. I've used the STM32C0, personal favorite, and some low profile key that the guys from ZMK recommended. That was good.
So is this like plain Zephyr or is this the ZMK that you're done?
No, I use my own firmware, but arguably I could have put the ZMK on it. It's just that I like to use it for testing stuff, so I want to be on main. So yeah, no ZMK. ZMK is a bit behind. By the way, ZMK, I think they just upgraded to Zephyr 4.1. So a few new features. You can use some of the new input driver. So yeah, good
Yeah,
stuff.
which is, I mean, it is a couple of releases behind, but it's still a major. There was a gap they had to fill, I guess, because they adopted or transitioned to the new hardware model,
Yeah.
like whatever version they were based on.
Big change.
Yeah, big change. But yeah, this is great.
Yeah, it's really good. Yeah, anyway, good event. It was great to test some devices in the field, try to see how they perform. So it was good. I have a project for next year as well. It may become a yearly thing. And the other fun thing, we mentioned one of the new driver last week. This was the TPS 55287. It's a power supply from TI. I brought the data sheet with me on the airplane. So I guess people read books. I read data sheet. What can I do? And I made a board with it. It's actually a really interesting part. I didn't realize it's designed for power delivery, and it has some feature that you don't normally find. At least I never seen them in power supply, such as feedback compensation for the drop on the cable. Like you're doing a power supply with a 2-meter cable, you're going to have a drop on the other end. So this device has a current sensing, and when it senses that the target is pulling power, it's going to raise the local voltage. Anyway, it's really cool. So I made a board with it, and I'm probably going to end up sending patches for configuring the stuff because it's not supported.
Yeah, I was going to say, like, well, do we have like this compensation stuff? Like, would that be a custom extra API on top of the regulator API that we have, or?
Yeah, it has to. So when you write a driver and you bump into this feature that are specific to that device, you have to take a decision on whether to expand the API, in this case, the regulator API, and add the support for a generic way to set this thing at API level, or what you can do is you just do a global function call for that specific device, and in that case, you obviously lose portability. So I suppose that in this case, since I don't really have an overview whether on this is a common feature or not, I suppose it is, because it sounds like every power supply should have it. But this is the first driver that I see that implements it, so I would probably propose to just have it as a device extension, which means just doing the global function and a header in include slash with that device. And then if the reviewers say, hey, this is worth a public code, which I don't think is going to be the case, then we can expand it. Probably it's going to be somewhere in the middle. Like initially we'll do it as a driver specific, and then in the future, if someone else tries to do it, we'll do a generic one.
Yeah, because it almost feels like even if whatever other regulators we have in Tree, even if they don't have that feature built in, we could like think of a generic driver that uses an external current sensor and does the regulation could be done by Zephyr proper. Like, does that make sense?
Yeah, it could be a thing. I wonder. Yeah, I don't know if you designed a lot of power supply and you know if this is a common feature. Like, let us know because we don't.
Yeah, but yeah, sounds like an interesting part indeed. What? So yeah, I was traveling. I tried to keep an eye on some of the news. There were some news from our friend Robert from Microchip. The leak detector is back. There was a nice blog post about like we've mentioned that, right? I think there was a couple episodes. There were a couple episodes where we mentioned this part from Microchip, which I think Robert used in a sort of like a scenario where he built some kind of like greenhouse monitoring thingy.
Yep. I think that the leak detector is going to become a recurring theme of the podcast. It's just I'm here squeezing my brain trying to find an application for it. I want to design it in a board. It keeps coming back.
Well, you have a part with like that's able to manage high currents, etc. Like you want to protect. I don't know.
Yeah, maybe.
But yeah, so I mean, that was an interesting read. We will put the link in the notes. It's always nice to see folks like building stuff end to end and like sharing about their journey. Here, some of the things Robert was basically mentioning is that he had this developer kit and like he got Blinky running and then wanted to try more advanced examples with like networking and HTTP servers and whatnot, and it almost immediately just worked. It is basically what he's saying. Just a bunch of like configuration things to change here and there. Yeah, it's cool.
Yeah, so this was using some E54 in using Ethernet. So I guess it's an Ethernet connected leak detector. Very, very good. I like connected application. Talking about connected application, what would you use if you needed to do leak detection in space?
Exactly. There was so that was I can't believe neither of us ever heard of or ever seen that before, but I guess that's because we don't put things into space, right, Fabio? Like, when's the last time you built a satellite?
This was
plane trip. Right. But we have folks in the community. We actually mentioned last week the board from Space Cubics that is effectively like a hardened piece of hardware that people are effectively sending to space in things like CubeSats, those modular satellite that university students and whatnot, like random projects that end up being shipped to space. And it turns out that there is a protocol called CSP, the CubeSat protocol, which happens to have an implementation out there available based on Zephyr. And so someone, this is also a reminder to you folks, someone basically submitted this library so that it gets added to our awesome Zephyr RTOS awesome list that we have up there on GitHub, so that it helps basically people discover it and hear about it. But yeah, like that seems to be an interesting protocol, almost to the point where maybe it's actually applicable to things that are not necessarily in space. Like Fabio, did you have a look a bit at like how it sort of like works, or like what makes it different from others?
Yeah. I tried to figure mainly what is it based on, and it looks like it's a fairly flexible piece of software. It seems like it initially worked over Canvas, which for a satellite seems like the right thing to use because it's fairly automotive. But anyway, no, it works on a bit of everything, like Ethernet. They mentioned that it's a pseudo UDP protocol, so something worth trying. But yeah, anyway, Ethernet, RS-232, Canvas, obviously. So yeah, one more RPC kind of thing. I think I'm gonna look into it because these stuffs are nice.
So yeah, it's called lib libcsp,
libcsp.
and this is sort of like natively Zephyr. So it's it's quite cool.
Yeah, seems like a fairly mature project as well. 2,400 commit. Good stuff.
Yep. All right. So trying to think of, you did a really good job with the previous transition. It feels like there is a transition hanging there for, next topic we had on the list is biometrics. So I'm sure we could make some jokes or like transitions on like Androids or whatever. But there was this interesting discussion in RFC. It was discussed earlier this week in the architecture working group, but the RFC proposal has been around for a couple of weeks, basically proposing the addition of a new class of drivers for biometrics sensors. I guess but it's not necessarily sensors. Actually, it's more like things like fingerprint sensors, facial recognition, those things that, yes, you could sort of implement as good old Zephyr sensors, but it turns out they have some features that make them sort of their own class and category of devices. So I wasn't able to attend that meeting where it was discussed, but Fabio, maybe you want to share a bit about like what's happening there and whether you think it's cool.
This took the bulk of the time for this week architecture working group, and I think it's an interesting topic. Most of the discussion was around the naming, as it often happens in these cases. So biometrics is probably not going to be the final name. It looks like it's more about authentication, like user authentication, because it's going to cover stuff like fingerprint sensor, face recognition, things like that. So interesting.
I think just cutting you off there, but I do think actually where I left the discussion, it might actually be the right term. Like things like IEEE and others, there seems to be sort of like common agreement that this kind of thing is called biometrics. Might not be the perfect word, but if this is what's commonly accepted.
The counter argument is that you could use biometrics for stuff like heart rate sensor, blood pressure, like anything that is tracking how the body works, right? Anyway, it's just a name, right? It's not super important.
I think Android calls it biometrics, for example, like that class of whatever. Go on, please.
Anyway, so the initial device is a fingerprint sensor, and the API is going to cover things like provisioning, unprovisioning, and authentication. So this is something to keep an eye on. Interesting stuff. These things are useful, right? If you're doing a device that needs to authenticate the user before operating right now, you have to do the integration from scratch. So having a reusable API seems like a worth addition to the RTOS.
Right. And as always, when these things happen where we think about adding new classes of devices, one thing that was asked to the author, and that makes a lot of sense, is like, hey, how would it look like if you were to implement another sensor? So I think that's what they are looking at right now, like implementing maybe a couple others, other drivers for other devices. And maybe that's you listening. Maybe you have biometric sensors that you want to use, or you have drivers that you want to import. Like give it a try. Have a look at how the API feels like, looks like today. There might be things that are missing or not that well suited for facial recognition, because like I think initially the focus was more fingerprint. But yeah, it's we'll put the link to the pull request in the RFC. Good stuff.
Good stuff. So talking about facial recognition, did anyone recognize your face in Paris?
Wow, you're doing good.
It was bad.
I wasn't. Yes. Short answer is yes. I was at an open source conference in Paris earlier this week. Well, actually, just yesterday and the day before, and the topic of the conference was all things open source, not necessarily in the context of embedded, more in the context of like business of open source and like governance models, etc., etc. But a big topic, although not quite as big as I thought, but there were definitely a few talks about it, was the Cyber Resilience Act, which, do you know what that is, Fabio? You've heard of that?
Yeah, I did. Yeah. It's
right.
It's one of those European things. But yeah,
it's one of those things that are going to keep people busy. And if it's not already keeping you busy, it's you might not have been paying it enough attention. But this is basically a European sort of like a regulation that entered into force exactly a year ago, December of last year, and that aims at establishing requirements for the manufacturers to make more secure devices and be better at all things security. And no matter what kind of, I said devices, I should actually say it's products with digital elements. So for us, I guess in Zephyr land, we immediately think of like devices like routers, wearables, home automation devices, you name it. But this is effectively anything that has software in it. So it could be like pure software solutions as well. And so as soon as you're making available in the EU market, something like commercially making available something that has digital bits in it, then CRA applies, and you need to comply. And and if we are to focus on the embedded aspect of it, and this is things like making sure that you have a software bill of materials for the device, like for your device to be CE, to have the CE marking on it. You need to be able to demonstrate that you're effectively documenting all your dependencies. And so depending on the category of devices, I'm trying to give you sort of like the short summary, but there's lots of resources online. I will link to my slides as well if people find this helpful. But what the regulation says basically is that depending on the category of device, ranging from just like a simple Wi-Fi light bulb, which is pretty harmless in a sense, all the way to something that would be, I don't know, like a sensor in a red light, like the traffic control thing. Like the former is really like pretty harmless, so you can basically do self-assessment of all the things that are asked for you to comply with. You can be like, I did my due diligence. I fixed the CE marking, and I'm good to go. But if it's a device that's more like important, like they say, like something that is deployed on the energy grid or transportation grid and things like that, then you need to sort of like get certifications from third-party authorities, etc. And if you don't, and maybe that's also should be part of my summary, if you don't comply, there's an incentive, or rather like penalties and fines that are very significant. Like you can be fined all the way to like 2.5% of your annual turnover.
Wow.
So like you need to comply. And my guess is that many folks, and I'm not a lawyer, so like don't take anything I said as legal advice, but my guess is that at least like people who are already building solutions on top of Zephyr, and just generally speaking on top of open source solutions, they have like internally, they've put in place some best practices, I would hope, in terms of like documenting where they get their software components from, etc. Or if they haven't, like with things like Zephyr, you can get a lot of the things that are asked from you by the CRA. You can get those, right? Like in West, you can when you build a project, you can ask West to give you the SBOM for your application, and like it looks at what CMake is pulling, and it looks at all your modules and whatnot, and you get the SBOM. So you can tick quite a few boxes from what CRA is asking. But people, if you haven't paid attention to CRA, please do. Yeah. I mean, again, lots of resources online, and the Zephyr project will also try and document better, like sort of like FAQs and the guidelines for manufacturers in the project. But yeah.
So there's something about having to provide the firmware update for like 3 or 5 years into this, right?
Yeah, that's actually a good, really good point. What the text says is that your product, you need to be able to you need to be organized and be able to demonstrate that you will deploy security updates for a minimum of 5 years, which is a lot, and which for people who are following, this kind of aligns with a recent change in the Zephyr project, where now our LTS releases are actually going to be maintained for 5 years, which means that as a manufacturer, you build your solution on top of Zephyr LTS. It's going to be much easier. Like, one, you know that the fixes will be made available, and two, I mean, it's much easier to backport them because, like, I mean, that's how it works, right? And so you can tick that box too. So yeah, that's a
right.
But
yeah, so it means there's probably an extra incentive for a design to be based on LTS, but also probably to be able to jump to at least one LTS so that you get the extra step, because you're obviously not going to release your product the day that LTS is released.
One thing, and it's kind of like a side note, but looking at the text, one thing that is kind of like oddly formulated, but one thing they say is that you need to like prove that you will be maintaining the thing for a minimum of 5 years, or less if your product has a shorter lifespan or life cycle, which kind of made me think, I wonder if some people will try to rig the system and be like, oh yeah, we're going to do like the whole planned obsolescence thingy, and
by design,
no, our stuff is just throw away. We don't need to maintain the security stuff.
Planned obsolescence as a feature. This is interesting.
Yeah.
Wow, this is interesting stuff. Yeah,
and it's actually not a terrible read. Like, I am, again, not a lawyer, but it's quite interesting to see how this is all like structured, and how they have all those like in the preamble, they have they set really the context. Like, they try and define things that are. We have those challenges in the project as well, like defining things like what is an open source project, what is open source contribution, what is software, what is digital, blah, blah, blah. And also, interestingly, I had no idea until a few months back when I started to look into this, but the EU and the European Commission, when you look at the text, like, you can actually read it in whichever is your native language. Like, this is available in all the like EU languages as sort of like authoritative version in PDF, HTML, and whatnot. So that's also quite interesting, and that's quite a lot of work, I guess, that went into that.
Excellent. So this is the response of the S in IoT is for security.
Yes, exactly. But it's good stuff. In general, it goes in the right direction, I think.
Cool. Should we talk about LVGL accelerators?
Oh yeah. Oh, no transition? Like, what?
No, I can't. Sorry.
Like, I was doing my monologue, and I thought you were working on the transition in the meanwhile.
I think we're out of transition budget for this episode. Sorry.
Yeah, we need a transition sponsor. This one just showed up in my LinkedIn feed. The LVGL guys are obviously really active. There's always a lot that's coming out of the project. So for those not familiar, but LVGL is basically a graphical user interface toolkit mainly for embedded devices. From the really small to those devices that also have graphics acceleration capabilities. So LVGL does support a bunch of those accelerators that you find in some SoCs. And this week, apparently, they were able to demonstrate that you can also rely on external graphical accelerators. So they call it GPU. I think, I'm not quite sure, like, that the actual chip that was demonstrated in this example was what we would typically call the GPU. But anyhow, this is an FTDI chip, I think. So that has the ability to do things like, I guess, like accelerate a blending of images and this kind of stuff. And when Fabio and I were looking at this in slightly more details, we were like, oh, but that part,
we have a driver for it.
We have a driver for it in Zephyr. So maybe, yeah.
Yeah, so we're not entirely sure how this works in practice in Zephyr, but this is something that apparently, we had a driver for a while, but it was mentioned in the latest LVGL upgrade, 9.1, I think it was. So yeah, it looks like you can buy and connect a graphic processor via SPI to your general purpose system on a chip. I want to see a demo of this. I want to see how it works.
Yeah. And what I would like to see as well, maybe this will be an opportunity or a reason to revive some of the discussions that happened maybe a year ago. I think it sort of like slowed down since then. But at some point, we were discussing whether there could be in Zephyr a graphics acceleration subsystem and an abstraction of those things that I just described. Like you want to like blend two frame buffers together and like draw like vector graphics and whatever. It would be nice, I think, to have this kind of high-level abstraction in Zephyr. If there are people in the community working on this, like please do chime in on join us on Discord or like reach out to Fabio or myself. Like I think there's there's probably sort of like a critical mass of chips available out there and SoCs with those kind of capabilities that it would actually be a really good addition, I think, to Zephyr.
Yep. Is it time for a coffee break?
Oh, yes. This one was also really nice to see. I think this is also something that showed up on my LinkedIn feed. This is from Simon Weiss. This is a project where we will be linking the GitHub repo, but this is one of those weekend hack projects, I guess, where what Simon did is that he hacked an espresso, not an espresso, a Senseo coffee machine, so that he could control it remotely over Bluetooth. And he published the code. Maybe not the schematics just yet of what you need to do to resolder and potentially fry your coffee machine. But what I found interesting in the project, if you look at the code on GitHub, this is one of those projects that I see more and more of those showing up on GitHub, where when you look at the code, it's pretty straightforward. Like coming, and we've been mentioning Arduino many times in the past. Arduino projects, it's like usually just a couple lines of code and not a couple lines, but a couple files, and it's pretty easy to skim through. We start seeing the same for Zephyr. Like people put their Zephyr-based projects out there on the internet, and it goes straight to the point, right? Like here, this is a coffee machine, and you don't have that boilerplate code, right? Like it's
not much,
right?
Not much boilerplate, right?
Exactly.
Coffee machine, boiler.
Don't explain the jokes. People are smart. Okay. We have smart engineers listening to us. But I think that's cool. Like, and this is one of those projects where, I mean, you're not super sure how to actually use Bluetooth for a project, how to do GPIO, like. Because I guess, did you look at how he's actually like controlling the coffee machine? I guess this is just a GPIO, right?
Yeah, so it's a I think the reason why there's no schematic is that he probably didn't make a board. This is an ESP32C3, but there is an RTC connected to it, an external one, so there probably is something. And at the end of the day, it's a GPIO controlled via Bluetooth with an ESP32, and I suppose since he has an RTC, he probably wants to wake up and find his coffee done already. So it's cool. But
it's not, I think so. Like whatever the Bluetooth service, I think is exposing a couple, a way to set the alarm and stuff like that, and to automatically control the thing over the air. That's that's cool.
Talking about GPIOs, Is your coffee machine GPIO active low or active high?
Yeah, tell me more about it, because I think it took me, years, I guess, to understand in device tree and whatnot, what is the whole active low pull up active, it feels like you just sometimes you copy paste without necessarily thinking twice, and that applies also for the LEDs sometimes,
but one place where it often applies is for reset pins. So this is a bit of a service announcement. So GPIO, the GPIO API that we normally use in Zephyr, refer to the logical value. So when you do a GPIO set DT or GPIO set, the value that you put, 1 or 0, true or false, refer to whether the signal has to be logically asserted or not. So, for example, for a reset, if you want to reset the device, you would always have GPIO set true or 1, or you would initialize it saying initialize active. Now, whether that translates into a physical high or low value depends on whether the GPIO is configured as active high or active low in device tree. And the reason why we have this is so that we can have a generic API that then result in doing the right thing, and it's portable on different board, because different board may have a different physical level for the same logical value. So the reason why I'm bringing this up is because I was working on a board with Ethernet PHY, and I checked the datasheet, configured the pin as active low because it's a reset, it's active low. Most of the time your reset is active low. And then I've run it and nothing worked. And then I found that it was defined incorrectly in the driver. So at this point, you have to decide whether you want to fix it and fix it in the code and break all downstream users, or leave it as is and then wait for someone else to fix it and break you. And the choice is always break the user. I mean, breaks my heart, but I'm sorry. So yeah, if you're writing a driver and you're using a GPIO and you have a reset, you probably need to set it active low and then do the right thing in the code, because otherwise somebody else is gonna get confused and fix it and break your board. So yeah, GPIO, get them right, do the right thing.
Yeah, and speaking of the device tree, we've been doing quite good with the transitions, but with the tech talks lately. There is a tech talk coming up next Wednesday, so the 17th. On next Wednesday, we will have a nice presentation. I think it will be an interesting presentation on a tool that the folks from Embedded have been working on, to have basically a visual tooling for all things device tree. A few months back, we discussed the language server protocol that people can use to edit by text their device trees and have like a nice autocompletion, etc. I guess this is taking this to the next level, but I'm really looking forward to learn more and see what they've been up to, because it is true that device tree is, the language itself is reasonably simple. I mean, not that simple, but it's all right. But then the way you, in Zephyr specifically, it can become a mess. Like you have tons of fragments of DTS files and DTS includes and whatnot. It's pretty much all over the place, and navigating all those and having a sense of, like, as a whole, what is it that you're currently editing for your particular board. It's not always obvious. So this is next Wednesday. If you RSVP on LinkedIn, YouTube, to make sure that you don't miss the memo. Anyway, you are already subscribed to YouTube and LinkedIn, I would hope, but just in general, you probably want to do that to stay in touch with the all the great things that come out of the Zephyr land, and like recordings from the various meetups that we're having, etc. But yeah, this will be next Wednesday. What else?
There wasn't a ton of stuff in the project in terms of new driver and board, but we have a couple of boards that we flagged that could be interesting. So one is the AI Tinker M6132S, complicated name, but they have the AI thing there. So I guess we have to talk about it, right?
And it has Wi-Fi 6 and BLE, so at least like Wi-Fi 6. That ticks the dual channel box for you, right?
I'm not entirely sure, to be honest. It may not be, but anyway, it's a Buffalo Lab BL61.
Yeah, RISC-V. Yeah,
RISC-V, interesting board, something different compared to the very common ones.
Yeah, form factor, it looks very much like an Espressif dev kit. That's kind of like
that's probably what they're aiming for. Yeah, something new. And the other one, which is kind of cute, is the M5 Stack Nano C6. So this is ESP32 C6. It's basically a Groove Wi-Fi gateway. Like, it's very small and you don't have much in it, but
yeah, I think I have one. And one thing, I mean, one thing that's actually really impressive, like, yes, it is small and it's light as well. Like, it's 2.5 grams, which is like, okay, like that's not a lot. And effectively, when you have it in your hands, it's effectively like weightless, I guess. But yeah, no, you're right. There were not that many. There's probably a couple other boards and drivers. But if we missed anything important, folks, just let us know. I think people might not mind if we skip really quick through the boards. But if we missed an important one, let us know on Discord, in the comments on Spotify, iTunes, wherever that is that you're listening to us, YouTube. And with that, I think, well, we will be back next week. And maybe after that, we will be making a short pause, I guess, for the holiday seasons. Maybe not, but next week, I think we're back for sure. Have a great week, Fabio, everyone. Bye.
Bye.